This is group A20, and we are here to show you nested quantifiers. So a little overview of what we're going to do today is we're going to go over the definition of nested quantifiers, translate it from English to logic, and then from logic to English, talk about the order of quantifiers, and then show you how to do some negation. The definition of nested quantifiers is a nested quantifier is one quantifier within the scope of another. So let's show you some examples of that. And first example is we have for all x there exists some y such that p of x, y. And then another one we have for all x and for all y, x implies y. So these are both within the brackets here, the all x and all y. Now, this is not a nested quantifier. For all x, p of x implies for all y, p of y. Now, this for all x applies only within the brackets here and here, and this for all y only applies within the brackets here and here. So those are your nested quantifiers, so now you know what they look like. Alright, so here we're going to give you an example of translating from English to a logical expression using nested quantifiers. So the sentence we're given is, for all integers x, there exists an integer y such that x plus y is equal to 0. So the first clue we have is the for all integers x, and that means we're going to use the for all integers symbol, and then we say there exists an integer y, and then such that x plus y is equal to 0, and the domain there is all integers for x and y. So this just says for all integers x, there exists one integer y such that x plus y is equal to 0. So that's using math, and then this one is a little bit harder. So the sentence we're giving here is, there's one person that everyone can fool. So let's say we have a proposition p of x, y, and this says that x can fool y, where x is a person and y is a person. Now if we want to say there's one person that everyone can fool, then we'll say, use the existential quantifier, there exists one person, y, that all people, p of x, y. So this says there exists one person for all x that p of x, y, which in p of x, y is x can fool y. So there's one person that everyone can fool. Alright, so now we're going to translate some logic expressions into English. And the logic expression we're given here with nested quantifiers is shown. And we have for all x and all y, where x is greater than 0 and y is less than 0, then x times y is less than 0. So we're going to make this a little easier to comprehend. So we have for all x and all y, where x is positive and y is negative, then x times y is negative. And that's how we translate from logic to English. So we've got the for all x and for all y. X is positive, or x is greater than 0, y is less than 0, or y is negative. Then x times y is less than 0, or x times y is negative. Alright, so here's another one. And this time we're given for all x, there exists some y, q of xy. So we're letting q of xy equal x sent an email to y. So what we're saying here is that for all x, there exists some y such that x has sent an email to y. And to make this a little easier to understand, we're just going to say that everybody has sent an email to somebody. And that's how we would say it in everyday talk, because everybody is our universal, that's all x, and has sent an email to somebody, and that's our existential qualifier. Alright, so in this one we're going to show you that the order of the quantifiers matters when they are different. And as you can see, we have the universal on the left-hand side first and second on the right-hand side, and then the existential is second on the left-hand side and first on the right-hand side. So what the left-hand side is saying is that if we let m of xy equal y is the mother of x, then the left-hand side is saying that for every person x, there exists some mother y. And I think we can all agree that that statement is true, but if we look at the right-hand side, this is saying that there exists some mother y who is the mother of all people x, which isn't true. So the order does matter when you have different quantifiers, the existential and universal. However, if you have the same quantifiers, you can switch them and it will not make a difference. And I'll let you convince yourself of that, but that also goes for the existential quantifier too. Alright, so now we're going to go over negation, and you can see up top here we have De Morgan's law for quantifiers. If you want to negate a quantifier, if you have the universal quantifier, you switch it to the existential and negate the inside over here. And the same thing is true in reverse for the existential. So here we're going to go over how to negate the expression on the bottom. So let's start by negating it. And that means that we change the universal to an existential and then negate the inside. Alright, and now we are going to again negate the existential quantifier now, which transforms into a universal, and then negate the inside. And that is how you negate nested quantifiers. So you just move the negation inside and make the appropriate transitions from existential to universal and from universal to existential. So thanks for watching our video on nested quantifiers, and I hope you learned something today.